This is geometry. This is the Unit 9 review. We'll just call that a 9. Alright, we're going to look at some vocab. F is a point of tangency. That means that the tangent line is touching the circle at exactly one point, and it'll be perpendicular to the radius. Angle FHG, that angle has a vertex at the center. So that's a central angle. Angle EBD, that angle there, that's an inscribed angle. That's because the vertex is on the side of the circle, edge of the circle. HG, notice that there's no arrows. HG is a radius. DB, again, no arrows. So this is a chord. C, so a point C, that is the center of the circle. BE, again, no arrows. So BE is a diameter. DB, from D to B, but look at the arrows. The arrows tell us that this is a secant. That means it's a line that goes all the way through the circle and touches in two spots. In AG, that would be a tangent line. You could call this an external tangent, because both circles are on the same side. That's in contrast to an internal tangent, which means that the circles are on opposite sides of the tangent line. This one, they're on the same side of the tangent line. Next, we're going to identify if AB is a tangent. Now this picture is a little silly because it has the 90 degrees, which pretty much indicates that this is probably going to be a tangent. But the way we would do this, we would look at the hypotenuse squared, and we are comparing this with the leg squared and leg squared. So this gives us 85 squared, and we're comparing that with 51 squared and 68 squared. So when we say 85 squared and we say 51 squared and 68 squared, we have our numbers. So we have 7,225, and we're going to compare that with 2,601 and 4,624. So when we add these two together, it's going to equal 7,225. 2601 and 4624 is 7,225. Yes, AB is a tangent, or is tangent to circle C. That's another way we could phrase it. So let's compare this one. Again, we're going to use Pythagorean theorem. We're going to compare it, so we're going to use a circle to represent comparing. because we don't know what's going to happen. We don't know if it's equal. Okay, we have 19 and we're going to square it, 16 and we're going to square it, and of course 8 and we're going to square it. So those are the numbers we're working with. We're going to compare that with 64 and 256. When we take the 64 and the 256, we're going to get 320. So that means that these are not equal. This one is larger, so this triangle is more obtuse than it is right. It is not tangent to circle C. It does not make a right triangle. Now for this one, we know that this is a right angle. We know that AB is tangent. What we're trying to solve for is X. Assume this segment AB is tangent. Alright, so we don't have to prove it. We're going to use it. So still are going to use this concept of Pythagorean theorem. So our hypotenuse are these x and 32. So we're going to add the x and the 32 together. We square that. The x is the other leg, and 56 is the final one. Now to square this binomial, you've got to write it twice. And 56 squared so we're going to FOIL this, so we multiply the front. X times x is x squared. We also take the x and we multiply the final one. So some call that the outside. So if we're thinking FOIL, F stands for front, O stands for the outer. Then we take the 32 and we multiply both of them. I stands for the inner, and L stands for the last two of each binomial. So we have 32 times 32, which is giving us 1024. Now we have simplified this down, so we're going to combine our like terms. We'll subtract our x squared, subtract the x squared. That's going to cross those out. We'll minus the 1024. And when we divide by 64, we get x to equal 33. So solve for x, and that's what we did. So feel free to pause the video and try this one. Calculator definitely helps since these numbers are so big. We have our hypotenuse, so that's our x plus 49, and we square it. X squared plus 63 squared. So we're going to have to do x plus 49 and x plus 49. That's going to equal x squared. And when we square 63, we get 3,969. So when we FOIL here, we get x times x, which is x squared. 49 and 49, which is 98. That was 49x plus 49x. This one is 49 times 49. We would subtract our x squared across. We would subtract the 2,401. Those cross out. We're left with 98x. These cross out. We get 1568. We can divide by 98. And we get an answer of 16. Here, see if I can use some different colors for us. What we know here, we know that a quadrilateral is inscribed in the triangle. Inscribed in the circle. For that to happen, opposite angles have to be supplementary. So we're going to solve for our missing angles. Well, let's take a look. First of all, that angle, that's an inscribed angle, and that opens up to this 80 plus 52. So the measure of angle J, which is x degrees, is going to be half of the 80 plus 52 degrees. That's going to equal half of 132, which is going to be 66 degrees. Now on this one, opposite angles are supplementary. So here we're going to be able to say that y plus 114 equals 180. When we subtract the 114 across, we get 66 for that angle. Just a coincidence that they're the same. We've got to use our eyes. We've got to think about what we have. It looks like we have the same thing. We can open up and we use our eyes. We come across here, we come across there, and we notice that they're touching this arc through here. So this y value, or angle F, the measure of angle F, is going to equal half of the 108 plus the 104. That equals half of 212. So that's 106. The measure of angle G, or the x value, that opens up and touches here, opens up and touches F. So it's 108 plus 75. Half of 108 plus 75. So that's 183. So that's 91.5 degrees, 91.5. This one follows our rule a little bit closer. where the opposite angles have to be supplementary. So 2y plus 104 is going to equal 180. So we'll subtract our 104. So 2y equals 76. We divide by 2. We get 38. Now that is not 38 degrees. 2 times 38 is what they're looking for. 2y equals, and that's what we had up here. 2y equals 76 degrees. And 2y is the measure of angle K. They ask us to find the measure of the angle where the variables are located. So the angle where the variable is located is 76. Okay, then our last one here, opposite angles, that's 110. So 5x plus 110 equals 180. When we subtract the 110 over, we'll get 70. And when we divide by 5, 5 goes into 7 once, so a total of 14. But we want 5 times that amount. And we have 5 times that amount. So 5 times that amount is 70. Find the value of the angle. The angle J is 5 times x. So that's 5 times x is 70. Looks like the directions are stuck on this side. We know we have diameters. We have to determine what type of arc it is. And we're going to figure out the measure of the arc. Well, let's work with this picture first, and then we'll go get all our answers. If we have 73, this is a central angle. A central angle equals the arc. If we had an inscribed angle with the vertex on the side, that would be half. But since the vertex is at the center, it's going to be equal. And this is 81. We know this is a diameter. So we have 81. We have a total of 180 minus 81 minus 73. That's going to give us 26 for this little bit. Now we know that since this is a diameter, these are vertical angles, so vertical angles are congruent, so that's 73, so this is 73. And if that's a diameter, that's a straight line, together they make 180, so this is 107, which makes this 107. So we found all the possible angles we can. Arc measures. I'll try to get the picture in here also. So NQ. NQ is only 2 letters, so we're expecting this to be less than 180. This is 181 plus 26. So that should be 107. 3 letters should be 180 or more. M, R, P. So that looks like the semicircle plus 26 more. So that's 206 degrees. This is a minor arc. This is a major arc. 3 letters is going to be 180 degrees or more. M and Q is going to be half the circle, so that equals 180. Call that a semicircle. MR, we already know that's 107. That's the advantage to calculating them first. PQ, we already figured that out to be 26. So this is a minor arc. We know that just because it's 2 letters, period. Minor arc, 2 letters. That means it's going to be less than 180, minor arc. 3 letters is going to be 180 or more. So M, then Q, then N. So that's going to be the whole circle. That'll be all the way around, not counting this 73. So we got 360 minus the 73, which gives us 287. And that's a major arc. Here we have an inscribed angle. The vertex is on the side. So the arc is going to be happen to be twice the measure of 37. So 2 times 37. That's 74. We need to find angle A. Well, if this is 132, the arc is 132. That's a central angle. That's BC. But angle A, notice, that's going to be half. So the measure of angle A, which is an inscribed angle, equals half of 132. That's again going to be 66 degrees. Here we're looking for this arc out here. That arc is the same as this arc. This is 48. 2 times 48, which is 96. Then we're going to have 360 minus 96. It seems to be 264. 264 is the rest. That's going to equal the measure of arc BCA. That's the rest of it, but we need to divide that into 2 pieces. So when we divide that in 2, we get the measure of AC to be 132. Here we're looking for the angle JKM. Looking for this angle here. Well, we know that it opens up, it's half of JM, arc JM, and JM is double 28. So 2 times 28, that's 56 degrees. So the measure of angle JKM equals 56 degrees. And an arc JKM. The measure of arc JKM is the whole circle. It's all the way around, but not counting this 56. So that should be 304. Looking for BAC. We know BAC is going to be half of the inscribed, or intercepted, it's called, intercepted arc. So that should be 79. We're looking for angle BAC and arc AD. Well, we look here, we have a diameter. So this is 180. So 180 minus 55. That makes us 125. And the angle is going to be half of that. 62.5. And then the arc, if this is an inscribed angle, the arc is going to be double the inscribed angle. Here we're looking for the small arc AB, and we're looking for the big BDA, everything but that. Well, this is 90. We know that this is a diameter, so it's 180 total. So these have to be 90 together, so this has to be 45. The measure of arc AB is going to be 145 degrees. And then the measure of arc BDA is going to be the 360 minus the part that we know. BDA is everything but the 45. That's 315. Okay. Now with this one, since they give us this value, following our notes talked about the measure of angle T equals half the big arc. Well, the big arc is going to be 360, not counting 114. So that is 246. That's all the way around here. So the big arc, 246, minus the small arc, which is 114. So the measure of angle T is going to be half of 132. Look at that. That's 66 again. Here we have a diameter. We're supposed to look at angle CBA. It's going to be a right angle. An inscribed angle touches the ends of the diameter. What's the measure of the inscribed angle? It's going to be half of the intercepted arc. So it's going to be 90 degrees. And arc AC, well, really, you're supposed to use 3 letters. So arc AC doesn't really exist. It's the measure of arc ABC. That's more accurate. That would be 180 degrees. Because that's a semicircle. Either way you go, it's a semicircle. You're supposed to use 3 letters if it's 180 or bigger. If the hypotenuse of the triangle in question 31, if the hypotenuse is 28 or 12.8, what's the radius? So this is 12.8 all the way across. We know that this has to be 6.4 and 6.4 because they are half. The radius equals half the diameter. So the radius is going to be half of 12.8. 6.4. Good luck.